In this virtual titration lab, I'll be preparing a dilute solution of sodium hydroxide and then standardizing this solution to 3 significant figures using potassium hydrogen phthaleate, which is abbreviated KHP. So now the materials we'll be needing is the sodium hydroxide solution. We'll be needing our distilled water, and we'll be needing a 250 milliliter volumetric flask. When preparing 250 milliliters of a dilute sodium hydroxide solution, if I was to choose 0.5 molar using the stock solution of 1 molar and the molarity calculation of moles per liters, I will need 125 milliliters of a sodium hydroxide solution and approximately 125 milliliters of distilled water. Therefore, I will duplicate my individual solutions, the water and the sodium hydroxide, in order so that I have enough. Okay, they're now duplicated. Now I'll be adding the total 100 milliliters of sodium hydroxide to the volumetric flask first. Okay, type in the precise amount, pour. Now I'll be pouring an additional 25 of the sodium hydroxide solution. Now I'll be needing to the remaining 125 milliliters with water. So I'll go ahead and add my water. I'll type in the precise amount for the first pouring. Now, in order to have a realistic amount instead of an exact precise amount, in order to duplicate what would happen in the lab, I'll be realistically pouring the remaining 25 milliliters of water in order to get a realistic figure. So let me hold to pour. So the total liquid we have now in the volumetric flask with the sodium hydroxide and the water combined is 250.16 milliliters. With my sodium hydroxide solution prepared, I can now standardize it using a pre-standardized solution of KHP, potassium hydrogen phthaleate, which would be 500 molar. Let me go and find it in my solutions. So the 500 molar solution of KHP will be needed along with the phenolphthalein, which is 100 milliliters and a 50 ml burette. So I can go ahead and remove my KHP solution, which I'll be placing back afterwards since my workbench is full. So I will add my 250.16 milliliters of my sodium hydroxide solution to the 50 ml burette. So I'll be adding realistically 50 milliliters. Okay, so now in my burette, approximately 51.4 milliliters of the sodium hydroxide solution. The solution does not need to be at the 0 mark to start, but the accuracy must be recorded to 2 decimal places. Now I'll be starting the titration by adding the sodium hydroxide from the burette to my KHP solution, my phenolphthalein solution, which was previously known as 1 milliliter. And now we can see that there is now 26 milliliters instead of 25. So now we know that the transfer of the phenolphthalein was successful. So now we will be realistically pouring the sodium hydroxide from the burette to the solution, the color of the solution changes. So we need to pour it till it matches similarly the milliliter solution of the KHP solution. I might have poured a bit too much, but we've seen the color change. And we know that approximately 26.430 solution from the sodium hydroxide was needed for us to see a color change. This should be repeated 3 times, which I will be placing my other 3 results in the end of this video to see which was the most accurate. As I previously said, the lighter the color, the more accurate the result. So when I compare my final 3, I will know which of the 3 experiments I did was the most accurate.